Dr. Grissom. This is going to be for the final project for embedded systems. And to start us off, I do have a document that I wrote as my plan to go in this because we don't just start writing code. We have to have a plan. So my first plan is I knew the idea I wanted to do, which was to build a time clock, and the reason for that is because I've been seeing a lot of employees take advantage of time clocks, and I wanted to try to make a secure time clock to contain every facet of your time, and so that you will not be taken advantage. Again, it will work for a minimum of 5 people for just a small startup company. And then we have the sensor, which is one of the requirements for the I2C that we'll be using to detect a hand. And then it will send that to the Google Cloud for the Firestore. And then another thing is a Bluetooth functionality for which the owner can connect the phone to the time clock to to be connected to the time clock, as everyone else has to scan their hand. He'll just connect the phone as just, again, to count towards that requirement. And then, again, the phone is catered towards the owner of the company, making sure everyone is being honest and logging in accordingly. And for the final project, again, I'm just going to be using a simple static order because if I did it dynamically, I would have to record videos each in the day incrementally, and that's just a lot of work and stuff. And I think you'll be fine with it just being static. But again, it is very easy to just change to a dynamic time clock, as we've done with the weather app. And so I'll be the first one logging in at 8 a.m. Then it will be you at 8:30, and then it will be my dad at 12, and then it will be my mom at 12:30, and then it will be my sister at 3. This means I go first, then you, and then the order just continues after that. And when it starts up again, it should have every name on there and who is working that day. Which is the names I obviously listed above. And then the B button will show the time they logged in for the actual daily inhabitants that they were there fully. So when it starts up, it will be using a 5-second interval for testing each person because we want a delay, which is that 5 seconds. And then that sensor shoots to the Firestore and then registers the name green. Every name will start red, and everyone will be green once their hand is detected. When there's no sensing detected for 1 minute, the device will just go to sleep to save energy. Just a nice little hidden feature there. And then when someone detected, there should also be an MP3 file that plays, which is one of the new ideas checked, which would just be like 2-second video. That's the sound it will make. And then I'm also going to be using a pub sub request to count the new features, which again I thought for being clocked in and stored. And then it's going to be an event-driven architecture, which is, again, trigger alerts for fraud, payroll processing. Again, PubSub is great because it keeps everything independently. If one thing goes down, the other will stay up, but still connecting those. And then, again, press B button when they see the daily login. Additional info, again, we're going to be using SPIFs, which is a serial peripheral interface flash file system, which is basically just how we play MP3 audio files directly from the chip's internal flash memory. So we will be utilizing that. And then what a pub sub is a name resource that acts as a communication channel where publisher applications send messages. What I perfectly described before. I just had ChatGPT make me a little thing here, a little graph here, so you can see how it's going to fully work, just as a visual representation if this was a full-on company. Next thing, let's get into the code. Again, I have all my comments here just to initialize what was going to be happening, which are the static employee order right here, what the phase 2 idea is going to be utilizing, what the phase 3 idea is going to be utilizing, and what the phase 4 idea is going to be utilizing. Along with the new features was the MP3 audio, which again, super difficult. And then we're doing the pub sub, which I did in the cloud class. And then a hidden feature because the device will go to sleep. Again, we include all of our libraries. We already include, again, our VCNL 4040, our sensor data. And then we also include our libraries for our Bluetooth. And then, since we're using MP3s, we have to include all the MP3 audios, which again is used to play audio, which again was very difficult to get working. And then we can, what this does is it clears the I2C sensor before the MP3 starts. So again, I was having issues where it was becoming staticky, so AI did really help there. Again, we're doing our Wi-Fi like we did before to connect to send that to Google Cloud. Again, Google Cloud Run URL, which again, this is our time clock URL, which is going to be winning Google Cloud. I2C pins, again, we've done this in phase 2. Then we have our VCNL 4040, and then now we start our hand detecting process. So we call our hand threshold, which again is 100. I did some testing; it was 140 to 170. So I stuck to 100. And then after that, we do our standard employee structure, which again is seen in our Google Docs, which is going to be our name, scheduled time, clocked in, and then actual time, which that will be the standard structure we will see when labeled into the JSON data. And then we have our employee list, which is, again, going to be our static list. Realistically, this would be a dynamic list. You have too many employees to just do a static list. But again, this is just for this project. So we're just calling all the names, false, 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 because they all start red, remember, so that's why they're false. And then we count to the next employee, which again, we'll repeat that soon. So again, start at 0, we'll go 1, 2, 3, 4. And then there's going to be a clock cooldown, which again, probably would bug out or just go super fast. Either way, we needed some type of delay. And so 5,000 is actually just a 5 seconds cooldown, which is clocking in, which we used right here. And then we do the hand state, which again, I needed to figure out. And after that, the hand must leave the sensor before another detection can be deducted. That's why we call false here. And then we say, then we work on our power saving, which again, I copied just from the weather app. We talked about this before. And then through that, we have our enum, which this is our standard screen states. And then after that, we start with our BLE variables. We've talked about that, which uses null pointers. And our UIDs, which again, you can generate these or take the ones from previous, which I just generated new ones. And this was for our phase 3. And then we do want to send one final message before connecting to know that the time clock is waiting. And then these are the MP3 objects, which is, again, thank God for object programming language. Again, we have to use a lot of objects for MP3 files. Next thing, again, we should be establishing is our function headers, which are all here. And then we call back our BLEs just as a professional level to know that the owner phone is connected. And then we always do the setup, which we've talked about before, which again, the operations is LCD is going to turn on, SD no, serial, yes. So we can look at our serial, which is happening down there, which again, it's in power sleep mode because I've not been activated. But if I click here, you can see it starting to move down there and it's in that JSON data. And speaker is true because it's always activating. And then we have our beginning. And then again, after that, once it begins, it wants the MP3 file to play, which should always be true. And then we start the LCD screen boot up, which again, we do all the drawing, secure time clock. Again, when it boots up, it should be all this, and it should just be white. It should be, again, the text colored white, and then a black background. And then it will just say starting, just so we know it is officially working, right? And then this is going to be the SPIS, which I talked about briefly. And so we do an if-else statement to just say, okay, if this is, again, working, or if this is not working, so we know that it is actually working, which, again, it will just say SPIS started if it is working. And then make sure, again, that the MP3 actually exists because we need to bring it into existence, which, again, we do another if-else statement. If it sees the clock in the MP3, then it will be found, and it should just start playing that, right? And then, again, we work on the external I2C processing, which we have done in phase 2. We start that sensor, which, again, pretty much simply copied a lot of the code, just changed a few variables. And then, again, this is a very crucial. Everyone should start when the device, until the sensor activates. When you have fully clocked in, it will count you. That's why we have a greater sign here. And then, less than. And then, again, I'm always first, so I start first. So that's why next deploy equals to 0, right? And then what the Wi-Fi should start off to save on Bluetooth functionality and power, because again, this was warned about, which I did have problems with. And then it will normally stay on until the hand goes off the sensor, and then it will turn back on the power, right? So we're always fluctuating between, okay, saving the power and then turning everything back on and then turning it off. And then we have our activity timer to make sure which time we're at. And then again, we have our main screen, and then we just loop that to update it. And then the MP3 again should consistently keep going within the loop. Checking that hand sensor to see if the VCN 424 is a hand sensor. And then the button B will be the middle physical button, and it will show the daily login for the day. If it was pressed, it's opening the daily login, and then we will see that in the actual hand demo. Once it shows the touchscreen, and then we have our power saving. This checks hand sensor for the phase 2 stuff. This reads again proximity for the actual hand detecting, determine that the hand is there. Only trigger when the hand again first comes near, and then which was simple doing an if else statement. We've done this stuff before, and then it now checks if a 5-second cooldown to make sure everything is going as planned. Again, we really need that delay because if we don't, the device will get really confused. And then the hand must leave before the next person. And then this must be always true to not confuse the sensor because, again, we will just have a bunch of numbers and people not getting clocked in, right? And then now, again, once it's detected, immediately clock in those employees, which this is what this clock in employee does. And then, again, this is just always safe to clock them in and make sure it detects the hand. And then it looks at our current employees, it attempts to clock it in. And then we use the static time in Google Docs to clock in the employees, which we use the get function. Again, it gets that timestamp, right? And then we save the static time indefinitely, and the employee is still red because, again, they still have not been clocked in. And then we send that to Cloud Run. And then after that, Cloud connected swimmingly. We sure get a green light when they clock in. And then we save and send the Bluetooth message, play the MP3, move on to the next employee, activate the cooldown timer, repeat, right? And so pretty much the same thing. And then just as if Cloud failed, we just have this. Then it returns the main screen, send to Google Cloud, all this. Stop the BLE HTTPS before the Wi-Fi connects to save memory. Again, the final document warned me about this. Then turn that Wi-Fi back on. Wait to the max of 10 seconds. Turn it back off. What if the Wi-Fi fails? It will print out an error. Wi-Fi connection failed, and then turn the BLE back on. Wi-Fi is finally connected again, and then the JSON objects, which should all be stuff I've already laid out: schedule time, actual time, timestamp. All these, it will compile. Then we convert that to the JSON string, serialize that JSON string, and then send that JSON, sending JSON over to Google Cloud. We have our secure client, again, start our HTTPS couldn't start, send the JSON, then we post that, right? And then it reads the response, and we close the HTTPS Wi-Fi off, and it keeps going, right? Bring the BLE back, cloud success, all the good stuff. We start service advertising, stop the BLE before the Wi-Fi, and then near the end here, what ended up happening was I was having really big problems with the MP3. So I just had AI help me write a few lines again to check. Where is it? Yeah, see, delete all old audio files, need to delete which previously. I had a AI to help me, but I do understand what it was doing to read these audio files because, again, it was just not working. You have to run it through a spiff, and then you have to run it in the file, and then you have to run the spiff library, and then you run the code. So it's really complicated. Clears the port. So this just makes sure it's very clean and digested before it fully runs. And the last thing that it does, obviously, it gets the timestamp, and then it tests the timestamp. We are really good. We are really bad on time here, but just to go real quick to the time clock, it imports the JAWS functionality. It shows the Firestore. Then we have the pub sub, which is new for the project, which uses the topics, Google Cloud Clients, which we've used in the past, call our variables, time clock HTTP function, only accepts the actual post request, read all that good JSON data from the MStat core too. And then we need to always include an employee so that we do this using an if statement, and then create a Firestore object. Again, cloud timestamp cannot be spoofed by the M5. Again, I looked this up, so I put research help to know this. And then divorce reported time, cloud receive time. Again, we did this in phase 4 before, which is just stores the clock inside the Firestore, which is the main thing, and then it publishes that same event through pub sub, and then we should always get that response back sent to the M5, right? And then just to make sure everything works, if we go to Firestore, As you can see, time clock logs, all of them are here. So it is being sent in real time. And then if we go to PubSub, we have our employee clock events right here. So that is working in real time with everything else. And then, yeah, that should be it. This project really helped me understand everything we've learned up to embedded systems and putting it all together, and what beautiful God giving powers, and how we can help the world building these actual devices, making stuff for honesty and loyalty. And this time clock again is not the most secure thing ever, as I needed to meet some requirements, but I did really work really hard on trying to make this the best as I could. And yeah, again, uh, really just simple time clock, but it is an effective use. And I think I've showed the Firestore, I've showed the code, I've showed the Cloud Run function. I think that wraps it up. Thank you.